Okay, hello guys. So welcome to my special episode for problem solving involving resultant force. As I promised all of you, I'm going to do a special episode for this video, so where you can do your revision on problems solving involving resultant force. So these worksheets you did it before this during the previous class. So this video will help you to do revision. You may just watch this for revision purpose. Okay, now let's dive into the question. Now, question 1 says, figure shows the thrust T and drag R acting on a motorcycle and its rider. The total mass of the motorcycle and the rider is 240 kg. Initially, both T and R have magnitude of 2,800 Newton. Describe the motion of the motorcycle. So then T is increased to 3,400 Newton, where R remains unchanged. What is the resultant force of the motorcycle? And calculate the accelerations of the motorcycle. So how to do the first one. So always remember, every time when you get the answer, you have to decompose the problems. Okay, this is part of the computational thinking that you have to learn. So you have to learn how to decompose the information from the question. So what I have here is I have my T and R have the same magnitude, which is 2,800 for T, and also R is 2,800. So what do I have here? I have T is equal to R. So don't forget to rewrite the resultant force formula. Now, let's say you don't write this one and then you directly want to describe the motion of the motorcycle, also not wrong, okay, because you know the concept already. But I'm going to explain one by one here. So I have F is equal to T minus R. It doesn't matter it's R minus T or T minus R because both the value are the same. So eventually you are going to get a 0 Newton in the end. Okay, next. After you get a 0 Newton, you are going to state it. Since F is equal to 0 Newton, therefore A is equal to 0 meter per second per second. So because the question say the motorcycle is moving, so that's why the motorcycle will move with a uniform velocity. That's the answer. Okay, I told you before there are two situations where acceleration is equals to 0. First is when the object is at stationary. Second, when the object is moving at uniform velocity. So that's what you learn. Okay, make sure that you remember that concept. Next one, I want to find the acceleration of the motorcycle. I'm sorry. Next one, I'm going to increase my T to 3,400 Newton, and then R remains unchanged. So I label it on the diagram. So what do I have here? I'm going to find what is my resultant force first. So how do I find my resultant force? Okay, I know T is greater than R. So F is equals to T minus R. Always remember the bigger value minus the smallest value. So 3,400 minus 2,800, I get 600 Newton. Okay, this is my resultant force. So how to calculate my acceleration? I'm going to use F is equal to ma, just substitute inside, and then I get A is equals to F over m, substitute the value, and I get 2.5 meter per second per second. Okay, easy, right? Now, next one. Question number 2. Figure shows a parachutist and his parachute that has just opened to produce a resistive force of 8,960 Newton. The total mass of the parachutist and his parachute is 80 kg. Assume the gravitational acceleration g is equal to 10 meter per second per second. So when you see this kind of question, don't forget to label all the forces first so that you can see what happened and how to form the formula. Okay, label it. Okay, now, so I'm going to label it. What do I have here? I have my resistive force is 8,960. I know that resistive force is, it goes up. So it's 8,960. Now, before I explain further, I'm just going to give you a situation. So let's say you are the parachutist and then you are going to jump down from an airplane. Obviously, you're going to fall first before you open your parachute. Now, eventually in that instant, when you open your parachute, there's a force that is going to push you upward a bit. And then only you're going to fall down. Okay, so that's what happened here. So that's why that resistive force actually refer to that instant when you open your parachute. So you're going to push upward a bit first and only going down. Okay, but then initially everyone will fall. If let's say you are falling without your parachute, you're going to fall with 9.81 meter per second per second. But the question here, we are going to use gravitational acceleration as 10 meter per second per second lah. So it means that without any resultant force, that without the resistive force, you are going to fall with 10 meter per second per second. But because you have you open the parachute, you have resistive force. That's why you're going to fall slowly downwards. Okay, now I'm not going to talk further about that. So what am I going to do is, okay, I will have to finish my labeling first. Okay. You know that all the things around us have matter. It's matter. Okay. It's made out of matter. So matter will have mass. Then mass is being affected by gravitational acceleration. So that's why it is equal to the weight. Okay. Then to find my weight, I have W is equal to 80 times 10, which is 800 Newton. Then I'm going to assume that going down as positive because the direction motion shows that going down, the things is going down. So my direction of motion is positive. And also my weight will also be positive. Then the one going against it will be my negative. So that's why I have F is equal to negative 8,960 Newton plus 800 Newton. Then I have F is equal to negative 8160 Newton. But do not forget to rephrase what do you mean by negative. So the resultant force is 8,160 Newton upwards. Now, let's say you say, teacher, can I assume that going up as positive? Yes, you can. But do not forget to rephrase in the end of the question. What do I mean by rephrase is the last statement, this statement. Here, this one. Okay. Now, so let's say you say, teacher, I want to let the going up positive, down negative. Okay, so you will have 8,960 minus 800. So you are going to get a positive 8,160 Newton. That is the final answer that you get. But don't forget to always restate it, rephrase it. So which we are going to write, the resultant force is 8,160 Newton upwards. Okay, so when you rephrase it means that you understand the concept well, and then you manage to tell me the magnitude and also the direction. We are not going to penalty your answer if let's say you manage to write this one. Okay, I don't want you to feel stressed why some books it use negative and some books it doesn't use negative. I don't want you to feel stressed about it. Both answer accepted as long as you rephrase on the situation. Okay, so you have to rephrase this one. All right, now next one. I'm going to calculate my acceleration because my value is my resultant force is in negative. So that's why F divided by M, I get negative 8,160 Newton divided by 80 is negative 102 meter per second per second. Now, let's say you ask me, teacher, if my answer is positive 102. Now, it doesn't matter. It doesn't matter because the thing is, you are only asked to find the acceleration. We are still going to consider you understand the concept of F is equal to ma. Okay, so it's the thing. Do not feel stressed. Why is it negative? Accepted. Why is negative not accepted? Okay, first thing is you have to use, because previously you are using 8,160 without negative sign, right? So you just reuse it in this question and then you find 102 meter per second per second. Yes, the answer is accepted. Okay, don't worry. All right, now I move on. So after you have this, you are going to describe the motion of the parachutist after the parachute has opened. So this is how I answer the question. First, when the parachute opened, in that instant, the parachutist is being pulled upwards by the great resistive force. Then after a few seconds, the parachutist will fall downwards, which his resultant force will be greater than the upward force. So the parachutist will experience a large deceleration and his velocity is reduced. So this is how I answer the question. All right, you may just reread it so that you understand what happened here. Now, question number 3. You may rewatch the video for your understanding. Okay, now let me just continue. Figure shows a metal block of mass 600 gram hanging from a spring balance in a stationary lift. Draw a free diagram for the metal block. And then what is the reading of the spring balance when the lift starts move up with an acceleration of 0.9 meter per second. And then the lift moves with a uniform velocity of 10 meter per second. What is the reading of the spring balance now? So that's the question. So first thing is I have to draw my free body diagram. Okay, now let's say when I want to draw, I just have to take this one into consideration. Okay, now what do I have here? I have weight. Obviously, I have weight lah. Okay, so weight is going down. And then I have another one is upward, which is the tension in the spring. Okay, tension in the spring. All right, now, next one. Okay, by referring to this, I'm going to find the reading of the spring balance when the lift starts to move out with an acceleration of 0.9 meter per second. Okay, So I'm just going to label everything here. Okay, A is equal to 0.9 meter per second per second. Then, okay, now don't forget when you want to find a weight, it must be in kg, MA, mg. So my weight is, my mass is 600. When I convert into 600 grams, this is typing error, 600 gram. So I have 0.6 kg. And then W is equal to 0.6 multiplied with 9.81. So I get 5.886 Newton. Now, from this situation, because the thing is going upward, right? So when the thing is going upward, then my T is greater than W. Now, some of you may be writing R here. Okay, it's not a big issue. If let's say you write an R is correct, okay? Because it's correct. The thing is going upward. So this is, if let's say you're using an R here, that is still correct. So I'm using a T here. So T is greater than W, F is equal to T minus W, and then MA is equal to T minus 5.886 Newton. So MA 0.6 times 0.9 is equals to T minus 5.886 because I got my weight here. Then I multiply 0.6 times 0.9, I get 0.54 Newton, and then T is minus 5.886 Newton. Then T is equal to 5.886 plus 0.54, I get 6.552. Why? Because I'm bringing this negative to the front, I get a positive here. Then I get 6.552 Newton. Okay. All right, then C, the question say, the leaf then moves with a uniform velocity of 10 meters per second. What is the reading of the spring balance now? So because it is moving at a uniform velocity, that's why my acceleration is equal to 0 meters per second per second. So what happened here? Because it is in a uniform velocity, so that's why I don't have a resultant force, right? So T will equals to W. T is equals to 0.6 times 9.81. I get my answer 5.886 Newton. Okay, so basically the concept you have to understand when it moves upward, when it moves downwards, and then when it is moving at a uniform velocity or when it is at a stationary. So that's the thing that you have to remember. Okay, now last question. Figure 4 shows an electric motor lifting a load of mass 50 kg using a rope passing through a pulley. What is the resultant force of the load? Calculate the acceleration of the load. Okay, now, so when you see this question, compared to my previous example, there will be slightly different. In the previous video that you see in the YouTube there, I have a trolley here, right? It's a trolley here. So do not feel stressed about it because I don't have a trolley here. So what I'm going to do is I'm going to just refer to this part. Okay, now for this kind of question, you just draw out the free body diagram. Okay, so I have my weight going down and then the tension is 750 Newton. How about the direction of the motion? The direction of the motion will be going up because the motor is pulling this up. So this is the system that I'm going to take into the consideration, only this part. Okay, so to find the resultant force, I am going to only see this part. Then I know that T will be greater than W. Why? Because it is moving upward. So T will be going greater than W, and then F is equal to T minus W. 750 minus 50 times 9.81, I get 259.5 Newton. So by using next one, I'm going to find my acceleration. F is equal to MA, A is equal to F over M, and then I get A is equal to 259.5 divided by 50, I get 5.19 meter per second. So that's what I have. Okay, so thank you for watching. I hope that you understand. If let's say you do not understand, kindly leave your comment or just ask me. Okay, so that's all for this episode. Thank you.